Welcome back to Godot Dev Checkpoint. I'm Spaghetti Syntax, and this is part 2 of the desktop pet series. Now, if you haven't seen part 1 yet, go ahead and go back and watch that one. Now, in the last video, we broke our pet out of the engine. He's free, but he's basically just a sticker. Now, he doesn't know where the floor is, and he doesn't know how to move. So, today we're going to give him a brain. We're going to write some script that detects your actual Windows taskbar and makes him patrol around your screen. Now, we also have to solve a thing called a pixel grid problem. Now, if you try to move a window using normal game code physics, Godot is going to crash. Now, I'm going to show you why and how to fix it using the vector 2i code. Now, let's dive in. Now, before we type, we need to understand the difference between moving a sprite and moving a window. Now, it's the bubble analogy. Normally, we write code like position.x plus equals 1. That moves the robot inside the Godot window. But the window is only as big as your sprite is. Now, if we move the sprite, he's just going to walk off the edge of the window and going to disappear. Now, we don't want to move the robot inside the room. We want to pick up the whole room and slide it down the street. Now, to do that, we want to talk to something called the DisplayServer. First thing we need to do is back in our project, in our script section of our main GDScript, we're going to add a couple variables at the top here. We're going to get a move speed to get our sprite moving. We'll start with 1. And then we also need a direction. And then we're going to direction to our vector 2. And it's going to be x1, y0. So we only want to go left and right. Currently right. Now we're going to dive into the process function. Now we're going to enter twice after our window resizable, backspace, make sure we're starting at the closest indentation to the start function, process, delta. Now first we want to get a window. So we're going to get the window, pretty self-explanatory. We just need a variable to put it in and get the window. Now here is the part where we have to differentiate between monitor pixels and game pixels. So your monitor is a grid of physical pixels. Now you can't be at pixel 10.5. Now we're going to use something called a vector 2i. It's an integer vector to tell Windows to move to an exact pixel coordinate. So something comment we can do with that, vector 2 versus vector 2i. Now say your monitor is a grid of physical pixels. You can't be at pixel 10.5. Now we want to be is evenly spaced. So we want to use whole numbers. So we're going to use vector 2i. Now the vector 2 and the I at the end is, well, integer instead of a float like a normal vector to tell Windows to move to an exact pixel coordinate. Now, how we're going to do that, we're going to calculate the move. All right. So we need a move vector basically. So we're going to do var move vector. Now we're going to use vector 2i. Now we want use our direction. So we want to know where we're going and we want to know how fast we want to get there. So we use the move speed we said earlier. And lastly, we want to apply that to the window, not the sprite. We want to move the window. So we want to apply it to the operating system window. And we do that by getting or setting the window position. Window position. We want that to plus equal our move vector we just made. There we go. Right, now our little caution we have here is just telling us we're not using our delta right now. If it really bothers you, you can get rid of that by just putting an underscore prefix on it. and then save the script. And if you want to dive into Vector 2i a little more, if you did or didn't know, you can hold down Control and highlight over any function you want to get deeper into, or callback, or whatever really, and click on it, and it'll lead you straight into the documentation. And you can read more about it and dive in as much as your heart desires. So really, I mean, that's it. We just need to run the game and see what happens. So when we click play, I'm just going to run the project and watch what happens. We now have our moving character. However, the robot walks to the right and keeps going forever and ever. Now he's got spirit, but no boundaries. Let's fix that part. Now we need to know where the screen ends, but we can't just check your resolution 1820 by 1080 because your taskbar takes up some of that space. Now we're going to have something called a bounce, so call it the bounce logic. So we're going to add this to the process function. So we're going to set something called the safe zone. So we'll call it the safe zone for your sprite. And then we're going to use something called screen get usable rect. Now this returns the screen area minus the taskbars and docks. So that's called screen get usable rect. Now this is going to return the screen area minus the taskbars and docks. And how we're going to do that? Well, we need to create a variable and usable rect. So it's going to be our usable area. And we're going to use something called a DisplayServer. Now we want the function or the call we just talked about, screen get usable rect. Should autocomplete. Can tab to finish it. Now what is the DisplayServer? Well, if you go into the documentation, you can see it just handles everything related to window management. So as it said, it's separated from the operating system as a single operating system may support multiple display servers. So it'll help us control it individually from everything else. Now, why can't we use position.x like a normal game object? Well, normally everything in Godot lives inside the scene tree bubble. Position moves the sprite inside that bubble. But we want to move the bubble itself, once again. We want to move the window, not the sprite. Now, DisplayServer is the translator that talks directly to your operating system, the Windows or Mac. And we aren't asking Godot to move. We're asking Windows to move Godot. Now for the screen get usable rect, why not use screen get size like your resolution? Well, if we use the full screen size, our robot will spawn behind the Windows taskbar, and the user will never see them. So usable rect specifically asks the operating system where is the safe zone that isn't covered by a taskbar or a dock. All right, now we have the usable area. What we also need is to check for the edge. So we'll check the right edge here. Now, say if the right side of our window is greater than the right side of the screen, then we want to turn around, basically. So we're going to check if the window position .x, so if we've reached it on the edge of our window we're using, plus the window.size.x is greater than the usable rect that we just set, the end of it, .x, we're going to flip, reverse math basically. Direction.x equals -1. Reverse math, subtraction. And I use reverse math. Here we go. And we want to get our sprite. And if you didn't know, use the $sign to get a node in your scene tree there. So we're going to get our animated sprite 2D, or whatever you named your sprite, and we're going to flip it. Or flip it on its H. horizontal. We're going to flip equals true. And we're just going to flip the visual. There's that. But we also need to check the left edge, or else your sprite will just walk off the other side. So check left edge. If I could spell check left edge. Now this is going to be if the left side of our window is less than the left side of the screen. So if our window is touching the edge of the screen, basically. Now we do if, then we can do elif. So basically an if else. Elif window dot position dot x is less than our usable rect dot position dot x. And we are going to flip again. Dot x equals 1. So reverse math. And then we need to get our sprite. So animated sprite, flip on the H again, equals false. So we'll set it back to its default position. So that's really it. Let's give it a test. Just hit this play button up here. And we're going to maybe speed them up a little bit. Move speed to 2. Save the script. And run the project. See where our guy goes. He's going to right to the right and hopefully, yep, there he goes. He's going to get to the right and we'll check the left side and boom, there it is. Now, we just need to get our sprite to find the floor. Now we're going to do that back up in our ready function. Now finding the floor. Now we need to get the safe area, just like we did with the left and right. We also need it for the gravity we're going to give. So in our ready function, go down the bottom, enter down a couple times, and we're going to find the floor. Find the floor. And the first thing we need to do is get the safe area. Get the safe area of the screen. Once again, minus taskbars, docks, those kind of things. Now we're going to use that with the same line we used before, this var usable rect DisplayServer. So var usable rect. Now we're going to equal that to DisplayServer dot screen dot, or nope, underscore get usable rect. There it is. And then we need to calculate the floor position. So where our taskbar is if it's on the floor. Now this one is going to be finding the Y instead of the X. Floor position. Now on this one, the end.y that we used, that we had before, the end.x, we need the end.y, which is going to give us the pixel coordinates, basically, where the taskbar starts. So end.y is the pixel coordinate where the taskbar starts. Now what we're going to do, we're going to subtract the window height so the robot stands on the line, not under it. So yeah, we subtract the window height so the robot stands on the line, not under it. We do that by setting a target. The target's going to use our usable rect we just set and our window size. So the var, we're going to use target. We're targeting the Y. So we'll do target Y, usable rect we just found, and we want the end.y. And then we want to minus that, subtract the window size .y. Go ahead and save that. Now we have it. Now we just need to get our sprite there. Okay, so 3, we're going to snap the sprite there. So how we're going to do this is we're just going to use that vector 2i again. So we use some integers. We'll get our x left edge minus, or we're going to left edge and use our target y, the floor. and we'll be able to get our sprite down to the bottom left. So x equals 0, which is going to be the left edge. And then we need our y is going to be the target y we just set above, which is the floor. All right. I'm going to do that by getting the window position. And we're going to set that to the vector 2i again, because we're dealing with monitor pixels, so we need to do integers, not floats. So we're going to use a 0 for the left edge and our target y to get the floor. And that should be it. Get our guy out of the middle of the screen and give him some gravity. And with that, we can give it a try. Go ahead and run your project. And we should see our sprite down. And it looks like we're 2 taskbars high. All right, a little bit of debugging here. I realized we set our settings in our code. So it'll work if we build the game, but we need the project to also run it the same way as the Windows operating system will. And fortunately, I missed a couple settings last video. Learning moment here. It's good to be able to problem solve, because that's what building games is all about. Now back in our project settings window, in our display in our window, initially we should have borderless and always on top checked. So now if you switch those on, our little guy should be on the taskbar. And there he is, writing right along the taskbar, just like we want him to. Great. Now it's because we use the usable rect. Usable rect here for the DisplayServer screen.usableRect. And that's the reason why we can tell where the taskbar is. Now we used to be able to move our taskbar. It should work regardless of where it is. But in Windows 11, well, Windows decided you're not allowed to do that anymore for whatever reason. So we can't test that part unless you have a third-party app. And let me know in the comments if it worked for you. Now this project deals with a lot of settings. So the cache can sometimes get a little finicky. So the cache monster, basically. Now, during my testing, I did run into a little bit of this from turning things off and on and off and on again a lot. So if you also have an issue like that, perhaps deleting the cache might help. How do you do that? Well, close Godot, go to where your project lives, open it up. You can find this .godot folder. Now this basically resets your cache, and it'll rebuild it when you start the game again. Let's go ahead and close that and open up your project again. And the one thing it does not change, if you click play after we delete the cache, you cannot move this embedded window, because what we did need to do, it's not saved in the cache, is go back to our game window, go to our 3 little dots, and turn this embed game on next play. And then we'll be back to normal. So embedding is disabled. Go ahead and run the project again, and our little guy is back to normal, walking along the taskbar. Now we got him patrolling the screen, bouncing off the edges, and respecting the taskbar. We have movement and we have a gravity, but he's kind of rude. If you click on him to say hello, well, he does nothing yet. He just ignores you and keeps on driving. Now right now, so he's just basically a moving image, and we want it to be a pet. Now in the final video, we're going to give more substance to the brain. We're going to program a state machine so you can click on him and make him stop. So he'll chill out. And we're going to use some pixel perfect stuff to make sure you can click only on his body, not the empty air surrounding him. Now if you found this helpful at all, or fun, please like, subscribe, and hit that notification bell. It really helps out the channel. And a special thank you to all our current and past Patreon and Coffee members. Your support really means the world. Now if you want early access to tutorials, source code, or suggesting future tutorials, please consider becoming a member yourself. The links are in the description, and remember, finished, not perfect. You'll learn more from failing than any success, so fail fast and fail often. And always stay curious. I'm Spaghetti Syntax, and I'll see you in the next one.